Hi everyone, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. The next topic in this lecture series of wireless communication is handoff, which is very important parameter needed in cellular mobile communication. So we often move from one place to another. So during traveling, definitely we'll be getting calls and we'll be on a call. So when we move from one area to other, the base station also will change from cell to cell. So our calls, which is already connected to one base station, has to be transferred to the neighboring base station wherever we are moving. So this process of reallocating the channels from one base station to the next base station is known as handoff. So this handoff procedure has to be done very smoothly without interfering the ongoing call. That is, the call should not get disconnected during the handoff. So handoff should be done at the background without affecting any ongoing calls. So in the handoff operation, basically we have two steps. The first one is identifying a new base station, and the next one is reallocating the voice and control channels from the old base station with the new base station. So first we have to identify when handoff has to be occurred. For that we have a term known as handoff margin. So this handoff margin is nothing but the threshold value. So when your signal strength goes below this handoff margin, then handoff need to be done. For every mobile user, acceptable amount of voice quality is there. So the minimum usable signal for acceptable voice quality is ranges between minus 90 dBm to minus 100 dBm. So handoff margin is given by del, which is probability of handoff minus probability of minimum usable. So this value of del cannot be too large or too small. When del value is very large, then unnecessary handoffs will be happening and it will be a burden to the cellular network. If del value is too small, then there may not be sufficient time available for a particular handoff to get completed. So value has to be an optimized value which satisfies both unnecessary handoff taking place has to be avoided, as well as proper handoffs has to be done. So this concept can be clearly explained by using this diagram. So here if you see, this is level at point A, and this is the handoff threshold value, and this is the minimum acceptable signal strength which will be needed to maintain an ongoing call. So you will see two conditions here: improper handoff condition and proper handoff condition. So in the improper handoff condition, so assume your mobile is moving from base station 1 to base station 2. So this is the A point and this is the B point where the signal is measured. So initially your signal level is at this point A. So when your mobile keeps on moving, your signal strength becomes reduced from the base station 1, because the distance between the base station 1 and the user is becoming larger. So when the distance becomes large, definitely the received signal strength will get reduced. Once the signal strength reaches the handoff threshold, then it has to be immediately reallocated. The channels has to be immediately reallocated to the new base station. If that does not happen, your signal strength will further get reduced, and once it goes below the minimum acceptable level, then your call will get terminated. So this is a case for improper handoff situation. So another case is proper handoff, where when your signal strength reaches your threshold, immediately the channels that are allocated with base station 1 is reallocated to channels in the base station 2. So once if the channels are reallocated to base station 2, then again your signal strength will get increased and your call will not get terminated. So this diagram clearly explains what happens if a handoff is not done properly and when a proper handoff is done. So handoff measurements, it is average measurements of the signal strength should be an optimized value. It depends on several factors. The main important thing is the speed of the user. So if the user is traveling in high speed, then handoff should be done very fast. If the user is traveling slowly, then there will be a certain time period to handoff. So this speed can be estimated from the statistics of the received short-term fading signal at the base station. One more important parameter here is the dwell time. This is the time over which a call may be maintained within a cell without any handoff. So this dwell time depends on several factors like propagation, interference, distance, and speed. Then the handoffs are of different types. So one type is the mobile switching center will supervise and it will make decisions whether a handoff is to be made or not. This is mobile switching center based handoff is used in first generation analog cellular systems. Another one is mobile assistant handoff. Here, the mobile station will make the decisions whether handoff has to be done or not. So this is used in second generation TDMA systems. And another one is inter-system handoff. Here, when you're moving from one cellular system to other cellular system, then the MSC itself will be different and you have to switch over from one MSC to other MSC. So this is a inter-system handoff. So and handoff requests are very important than accepting a new call, because in handoff you will be on an ongoing call. That ongoing call should not get disrupted. Next, we will see about practical handoff considerations. Since I told you already, there are different types of users. There will be high-speed users as well as low-speed users. So high-speed users will definitely need frequent handoffs, whereas low-speed users may not need frequent handoffs. So if we are using a common cell size, so for high-speed users, more number of handoffs will be needed, and for low-speed users, handoff will not take place. So in order to overcome this situation, that is in order to minimize the handoff processes for high speed users, and in order to accommodate both high speed and low speed users, we can go into a new concept known as umbrella cell approach, where you'll be using different cell sizes. So you'll be using large cell as well as small cells. So for large cell, you'll be having a high power antenna which will cover more area, and the height of the antenna also will be very high. Whereas for small cells, the height of the tower can be reduced and low power antennas can be used. So for both the high cell and high power and low power antennas, and different heights also will be present inside the umbrella cell. So this is a diagram which represents the umbrella cell approach. So if you see here, you'll be having a one large cell here, and you'll be having several small cells. So for this large cell, you'll be having a large tower at a height greater than this small cell's tower height, and you'll be having antenna here. This antenna will be having high power. For small cells, you'll be having small base stations as shown here, each with low power antennas. So this large cell will be used for high speed traffic. So whenever a mobile moves here very fast within this, handoff will not be needed here. So all that user, high speed user, will be accommodated with this large base station, and small low power users will be accommodated with the small base stations. So a single umbrella cell approach will accommodate both large or say high speed traffic and low speed traffic at the same time. Hope you understood what is handoff. So we'll see few assessment questions. What is the condition for handoff? Yes, as already I told you, a mobile which moves into a different cell from its already present cell while in an ongoing call or while in a conversation will definitely need handoff in order to avoid call disconnection. Next one is the time over which a cell can be maintained within a call within a cell without handoff is called. Yes, dwell time. So dwell time is nothing but the time over which a call can be maintained within a cell without handoff. Thank you for watching this video.